Here I will be discuss about the previous year question 2019 for the subject of DC machine and transformer. Here group A question number first is that in DC machines wave winding is employed for getting low current and high voltage rating. Okay, but in the last year question 2020, here lap winding is employed for getting high current and low voltage rating. But in this question for wave winding, the right answer will be option number B, low current and high voltage rating. Okay. Another question, second number, the number of parallel paths for a 6-pole duplex lap winding will be. For the basic theory for lap winding, the total number of parallel paths A is equals to 2 times of number of pole given in this question. Okay, here the number of pole is 6. Therefore, total number of parallel paths 2 times of 6, that means 12. Here the right answer option number C for question 2. Okay. Question number 3. Which of the following is not a part of DC machine? Here damper winding will not the part of DC machine. Field winding is present, armature is present, commutator is present for the construction of DC machine, but damper winding is not present. Okay, so the right answer for question 3 option number D. Question 4. In DC machines, the sparking at the brushes is due to armature reaction and commutation. Okay, in this question, commutation is not mentioned. Okay, here the right answer option number A. Okay, question number 5. In DC series motor, the torque developed before magnetic saturation is. Here for DC series motor, okay, DC series motor, the starting current is very high, or it means starting torque is very high, because torque is the directly proportional to the square of the armature current. Okay, so that DC motor T directly proportional to the square of armature current, so that right answer will be option number D. Okay, in the question 2020, the shunt motor is given. For shunt motor conditions, the torque is simply directly proportional to the armature current. Okay, but in case of DC series motor, here torque is directly proportional to the square of the armature. Okay, here armature current IA. Okay, correct answer option D. Question number 6. The speed of a 4-pole DC series motor at no load will be. Okay, in this question, this is the very important. Here no load condition is given. Okay, for no load condition, there flux is 0. Flux is 0 because speed is correlated with the flux. Okay, in this question, if flux is 0, that means there is back EMF will be not produced. Okay, in the back EMF formula, here flux is the directly proportional to the back EMF, but in case of speed, here flux is inversely proportional for the speed. That means if flux will be 0, then the speed is infinity, because flux is inversely proportional to the speed. That means infinity means enormously high. Okay, For DC series motor, the no load condition, the speed is infinity. That means option number D, enormously high, means almost infinity. Okay. For question number 7, the torque speed characteristics of a DC shunt motor is. Here the right answer option number C, a dropping straight line, because torque speed characteristics is gradually decreases. Okay, here this is not completely constant straight line, but here the shunt motor, the speed torque characteristics will be decreases. That means dropping a straight line. Okay, here the option number C is right answer for DC shunt motor. Next question 8. A 3-point starter is considered suitable for which DC motor? Here the option D is correct. Shunt as well as compound. 3-point starter, the shunt and compound motor will be suitable for 3-point starter. Okay. Question number 9. The inductive reactance of a transformer depends on leakage flux. This is the basic property of the core of the transformer. The inductive reactance of a transformer depends on leakage flux. The right answer will be option number D. Okay. Question number 10. A transformer is supplying purely resistive load. The power factor on primary side will be. This is also another important question. Here purely resistive given. Purely resistive means here power factor will be 1. Okay, the question in another word, a transformer is supplying unity power factor. Okay, in case of purely resistive. Okay, the power factor on primary side will be 0.95 lagging. Okay, if in this purely resistive condition, if power factor 1, okay, and another case if the load will be inductive or capacitive, so power factor is equals to 0. Okay, but in this question power factor is 1 for supplying, that means primary side. Okay, here primary winding will be the power factor 0.095. Okay, 0.95, almost 1. Okay, so that the right answer for question 10 option number A. Okay. Question number 11. The open circuit test on a transformer gives. Here this is the also basic theory. We have performed open circuit test to find out core loss or iron loss. Okay. The right answer option A. Here question number 12. Question number 12. The all-day efficiency of a distribution transformer will be high with low iron loss. Okay, this is another basic theory of the distribution transformer. Here, distribution transformer all-day efficiency will be high if iron loss will be low, because iron loss is present every time for distribution transformer, but copper loss occurs in case of load is connected on secondary side. Okay, here the condition is that for iron loss, okay, because iron loss present in every time. Okay, so the right answer for option for question number 12 option B. Okay, and next question 13. Eddy current loss in a transformer is reduced when lamination are thick. Okay, because the formula for the eddy current loss is equals to PE is equals to KE into B max square T square F square into V. Okay, here T is equals to thickness of lamination, V is equals to volume of magnetic material. Here B maximum flux density, F frequency, okay, Ke eddy current constant, okay. But eddy current is directly proportional to the square of thickness of the lamination, okay. Here if thickness of lamination is very low, then the eddy current also very low, okay. For low eddy current losses, thickness of lamination also will be very low, okay. So the 13th question right answer will be option number B, okay. Option number B is that lamination are thick. And another question 14, during short circuit test core loss is negligible because voltage applied across high voltage side in very small and hence a small mutual flux occurs, okay. Here for the short circuit test, if you remember about the circuit diagram, the secondary side is short circuited where low voltage given, okay, but high voltage side primary supply voltage given, okay. Here very mutual flux occurs and core losses is negligible, okay. For short circuit condition very small mutual flux produced, okay. So the right answer option number A for question 14, okay. Question number 15, in auto transformer the power is transferred to load circuit by both conduction and induction. Here question number 15 right answer option C, because in auto transformer a single winding is present, okay. Single winding, that means half portion considered as primary and another half portion considered as secondary, okay. But here n1 and n2 are different, but in case we considered conductive and inductive both the properties, okay. In an auto transformer the power transferred to the load by conductive and inductive, that means option number C, conduction and induction, okay. And another question 16, the iron core in a transformer provides low reluctance, okay, low reluctance path, ठीक है, okay. The iron core in a transformer provides low reluctance path to the main flux. Here right answer will be option A, okay. Question number 17, this is the numerical type question given in objective form, okay. Here there are two frequency has been given, at frequency 50 Hz and at frequency 60 Hz, okay. Here at frequency 50 Hz there are core loss will be given, that means in core loss hysteresis loss is 200 watt and eddy current loss is 100 watt at the frequency of 50 Hz, okay. So the total core loss at 50 Hz is equals to 300 watt, okay. But we have to find out total core loss at 60 Hz, okay. Here I have find out the solution in another page, okay. Here if you see properly, we have find out here at frequency 50 Hz WH is equals to 200 watt, it is hysteresis loss. WE is equals to 100 watt, it is eddy current loss, okay. We have to find out iron loss at 60 Hz, Wi iron loss, okay. Here Wi is the WH and WE, okay. Here the sum of WH and WE, that means WH hysteresis loss and WE eddy current loss, and Wi total core loss or iron loss. Okay, here the formula about the hysteresis loss, WH is equals to P into B max power to the 1.6 and frequency square plus formula of WE is equals to Q into B max square into F square. Okay, here the summation is that the sum of both these losses is called iron loss. Okay, in this case we have to find out P and Q. Okay, these are constant term. If we let us consider Bmax is same in both cases because there is no given data for Bmax. Okay, so that we considered as equal in both the cases. Okay, here P and Q are constant. There is only frequency is variable. Okay, so that if we written in terms of proportionality, that means WH proportional to F. Here WH is equals to P into F. Here P is proportionality constant and WE directly proportional to the square of frequency. Here WE is equals to Q into F square. Here Q is proportionality constant for eddy current loss. Okay, so that in terms of frequency and P and Q, WI is equals to PF plus Q into F square. Okay, in this case there is frequency given. Okay, if you calculate these formulas, then we have to find P and Q. Okay, here WH and WE has been given, frequency also given, so we have to find out P and Q for this condition. Okay, here if you put frequency, then the condition is that 50p plus 50 square into Q. Okay, here for hysteresis loss, WH is equals to P into F. That means WH is equals to 200 is equals to P into 50. Here P is find out, that is 4. Here 200 divided by 50 is equals to 4. Okay, and WE is equals to Q into F square. That means WE is 100 watt. Here 100 is equals to Q into 50 square. That means Q is equals to 100 divided by 50 square. That means 100 divided by 50 into 50. If you calculate these calculation, you find out 0.04. Here the constant value P and Q will be find out. Okay, P is equals to 4 and Q is equals to 0.04. Okay, here the condition is that frequency is equals to 60 Hz. The general formula Wi is equals to Pf plus Qf square. Here you put P and Q at frequency 60 Hz. Okay, so that Wi is equals to 4 into 60. 4 is equals to P and 60 frequency plus 0.04 into 60 square. 0.04, this is Q and 60 frequency. You solve these steps, we find out total iron loss. Here 384 watt find out. Okay, therefore total core loss or total iron loss at frequency 60 Hz is equals to 384 watt. Okay, so that the right answer for question number 18 is option number B. Okay, in the question number 18, the numerical questions is question number 17. Okay, and the next question number 18. In ideal transformer, winding should have, there are, this is the also basic concept for ideal transformer. There is resistance primary and secondary side will be 0. Okay, in this option there is option number D, no ohmic resistance on either side. That means primary side or secondary side there are resistance 0. That means no ohmic resistance means resistance is 0. That means ideal condition for primary and secondary winding resistance is 0. Okay, so that the option D is correct for 18th question. Okay, question number 19. Which of the following connection of a transformer will give the highest secondary voltage? Here, delta to a star connection give the highest secondary voltage. That is right answer, option number B. Okay, for lowest secondary voltage, if highest secondary voltage replaced to lowest secondary voltage, then primary delta to secondary delta has been no sorry here star to delta. Okay, star to delta connection is given for lowest voltage. That means a step down transformer is used. Okay, here the if the lowest voltage has been given, then the right answer option D for the lowest voltage. But in this question highest voltage considered. For highest voltage condition, delta to a star connection has been right answer. Okay, for question number 19th, right answer will be option B. Okay, and the last one is question number 20. Here instrument transformers are used on AC circuits for extending the range of. Here all of the above options are correct, because in the instrument transformer AC circuit for range extension, ammeter, voltmeter, wattmeter, all the parameters has been used. Okay, so the option number D is right answer. Okay, thank you watching for this video.